Hello, this is Jack Jackson. In this video we're going to see how to visualize all 6 of the trigonometric functions with some simple constructions based on the unit circle. And for this video I'm going to be using my Sketchpad Sketch Trigonometry Ultimate, and when you do contents we're going to go to this one that says Inner Angle. And this is part of the circular trigonometric functions section, and we can enter an angle and you type in whatever you want here, like 0.75 radians. I did 5 radians. I meant point. Let's try that again. 0.75 radians, and we get some angle. And of course, it will convert that to degrees here, at least rounded off to the nearest, however many decimal places it has here, 4, I think. Okay. And this will compute all of the trig ratios here, and it also reminds you the basic definitions. That if we take a point here on the terminal side a point on the terminal ray, initial ray of course is down here on the x-axis, the terminal ray is where it spins till it ends up, and that point A has coordinates xy. Remember the radius is 1. So cosine is x over r, which really actually is just x in this case, since r is 1. Okay, and that is, this case you can see that's about 0.73. And here we get y over r, which in this case is just y, since r is 1. And then tangent is y over x, which is 0.9316. Okay, and we get secant is r over x, but in this case r is 1 again, so this turns out to be just 1 over x. If we're looking at the unit circle. If we did a circle in general, we'd have to be sure to put the r in our formula there to make sure we have it computed correctly. And similarly, cosecant is r over y. That's 1 over y in our unit circle case. And finally, cotangent is x over y, which is given at the moment to be about 1.0734. So there are the 6 trig functions of this particular angle. So of course we can use this as a calculator sort of by just typing in the angle in radians. It will draw it to scale, draw the reference angle, and notice, remember, the reference angle is always drawn straight down to the x-axis so that we get a right angle right there on the x-axis. Okay, so now how can we see the trig functions on here? Well, 2 of them we can see very easily, at least their absolute values. So the cosine is going to be the absolute value of x. No, let me say that right. The absolute value of x is, that blue length is the absolute value of the cosine. So the x coordinate is there. Now in this case, x and y are both positive, so the x and y coordinates actually are this cosine and sine, which they will always be on the unit circle. X will be cosine of t, y will be sine of t, but those are actually these blue and red lengths. If we put it in a different quadrant, let's see, 1.75, let's try that. Where does that put us? That puts us in this quadrant here. Well, in this case, that's no good. The initial ray is always right there. There we go, that's better. So now the angle is going across here to the second quadrant, and so this blue length is the absolute value of x, and the red one is the y. So really, we can still go by the blue and red lengths, we just have to remember to put the correct sign, that is positive, negative sign on it. Okay, and the same thing works for the other distances. So let's go back to our 0.75 for our illustration. Now what I want to show you is how we can also see the other trig functions too. And what I'm going to do here is I'm going to draw in another some more things to the picture. And what I'm going to do is I'm going to take a tangent line to the circle at the point A. And this tangent line is going to touch right there at one point. And in geometry we learn that if it touches in one point, that makes a right angle right there. So now we've got several different right triangles in this picture. So first of all, let's look at this green length, and let's look at the triangle going from C to A to D. Okay, that's kind of shaded in blue here. Right angle at A. And let's look at this at our angle, which is here, our reference angle right here. And what would be the tangent of that angle? Well, it would be opposite over adjacent. Okay, so it would be this green length over 1, which is the green length. So the green one is the tangent of that angle, at least up to positive or negative sign with it. So if you follow that tangent line down from the vertex down to the x-axis, that length will be tangent. And that's going to work if we go over here and make this in one of the other quadrants as well. So let's make it bigger. Okay, this length out here is the tangent. It's going pretty long right now. Let's make it like this. And so here, this is again, that length is the absolute value of the tangent. So of course we know tangent is negative in this quadrant. But if you look at it, compared to this reference angle, that's opposite over adjacent is green length over 1, which has got to be the tangent of that reference angle. And of course we know that if we do the tangents, the sine, cosine, tangent, all the trig functions of the reference angle, that you get the same size for the answer. You just have to make sure you get the right positive or negative. So we can actually visualize the tangent as this length here, and then put the correct sign on it, which we know is negative at the moment. And let's switch back to 0.75 radians for illustration. Okay, so we can see the cosine is the length from C to B, from B to A, the vertical length in our reference triangle. That's the sine, or at least that length is the absolute value sine. This length is the absolute value cosine. And then the green length down here, that's the tangent. All right, now look at the let's look at this. Continue to look at this same triangle, but look at this hypotenuse of this triangle. It goes all the way from C out to this point D, where that tangent line meets the x-axis. Well, let's think about this angle. Let's think about the secant of that angle. Secant is the reciprocal cosine. Remember, cosine is adjacent over hypotenuse, so hypotenuse over adjacent would be cosine, would be secant. And so secant of this would be the brown length here, the hypotenuse, over this leg here, which is 1. So brown over 1 is brown. It's the length of this brown segment right down here at the bottom along the x-axis. So that is the secant of the angle. Okay, so again, if it's in a different quadrant, it might be that length would be the absolute value of the secant, and you just have to put the appropriate sign on it. Similarly, let's look at this triangle up here, the kind of brown triangle. Again, it's a right triangle with one of the legs here being the radius of the circle, so it's 1. Okay, now think about the way this is set up here. These two angles right here at C are complementary. So that means the one up here at the top and this one down here are complementary as well. So the angle here at C, which is our reference angle, remember from our original triangle, if we hide everything else, remember this is our reference angle right there. Okay, and that's the same size angle as the one up here. So those two angles are congruent. So we're looking at this angle up here from this right triangle. If we do, let's look at the opposite and adjacent, okay? Now, if we do cotangent, okay, let's think about tangent. Tangent's opposite over adjacent, so cotangent is adjacent over opposite. So that would be orange length over brown length is the cotangent. Well, that's orange length over 1 is orange length. So this orange length is actually the cotangent of that angle. Isn't that cool? And then look here at the hypotenuse. Okay, if we look at the opposite side in the hypotenuse, opposite over hypotenuse is sine, so the reciprocal of that would be hypotenuse over opposite. That's going to be cosecant. And so if we look at pink length over radius, that is cosecant, but radius is 1, so that is just the pink length. And so now we can see all of the trig functions here. Cosecant is this length, this vertical length here along the y-axis. Secant is the length along the x-axis. Okay? And they're along the axes. Okay? Then you look along the tangent line here, and you can see the tangent and the cotangent is the green and the orange lengths respectively. So the green length is the tangent. Up here the orange one is the cotangent. So cotangent is from E to A, tangent is from A to D. Secant is from C to D, and cosecant is from C to E. And of course, if the basic one is back to here, we look at our reference triangle and we see the red one is sine and the blue one is cosine. Now, these lengths are all positive. You have to put the correct sign, positive or negative sign, with the angle to make sure that we have the correct sign on it. But you can visualize all of those, and it doesn't really matter what quadrant it's in. Let me show you one other way we can visualize the tangent. Okay, so if I take this point here at 1, 0, right on the x-axis on the unit circle, and draw a perpendicular line to the x-axis. Now look at the right triangle formed from the origin out to this point up here, down to here, where we have a right triangle here. And this length here, let me draw a line segment there, and we'll hide this one. Okay, so that black line segment, let me go ahead and make it green, because it turns out to be exactly the same length as the green length here. Those two things are the same length. They're both the tangent of that angle. Let's see if I can convince you of that. So tangent of our angle T is going to be that length. We'll go ahead and make that green. Okay, and so there's our tangent. Okay, how can I convince you of that? Well, look here. This is a right angle right here. Let's see, we need a point there. Okay, now make that point a little bit smaller. Okay, and so we have a right angle there, so we have a right triangle. Okay, so what is the tangent of our reference angle here? It's opposite over adjacent, but adjacent is the whole radius of the circle here. It goes all the way from the center at C to this point D, which is 1, 0. Okay, and so that's a length of 1, so opposite over adjacent is green length over 1, and that's tangent, so the green length is the tangent. And this one kind of works out nicely because if it's pointing up here, we've got positive, whereas if we did a negative here, say negative 0.2, let's get rid of some stuff here, negative 0.2, now this will be pointing down, and if it's pointing down, the tangent is a negative. Okay, so you can kind of keep track of it there. It's kind of reversed if we're over here. Negative 2.2, well, actually what I can do here is take a whole line, okay, and I still want to find there we go. Give me just a second here. Okay, so if we extend that line here back up so that it meets this vertical line, then we can still see the tangent. That's positive tangent, which is supposed to be in this quadrant. And this ray is not hitting it, but the ray extended the other way is hitting this vertical line. And if you're in the second quadrant, let's see what would be something in the second quadrant. How about 1.8? Would that be in the second quadrant? Yeah, that's in the second quadrant. It's running off the screen down here where it hits way down here. But again, that's going to be a negative tangent. It's the opposite of that green length. So there's another way to see the tangent as well. So now we have some visual ways of seeing the sine, cosine, tangent, secant, cosecant, cotangent, all 6 ways, and we saw 2 different ways to see the tangent.